All I'm trying to do is put together the answer key. That's all I'm trying to do. That's it. Question I. The only type of error you can commit if you reject the null is a type 1. I don't think we committed a type 1 error here. Everything seems kosher to me. Wearing a tie is good. Now it's on to the next question. On to the next question. Why? That's weird. Anyway, what's the p-value? Rounded to 3 places. How much evidence do you have to reject the null? Is what the p-value does. In order to find the p-value, we need to take the test statistic of 2.42 to the z table. Z table, we need to find out how big the area is. And then whatever's left over in the tail, multiply it times the number of tails in the test, which is 1 because it's a directional test. Don't hit the wrong button. Don't hit the up. All right, good. Because they have stop screen share and stop broadcast they both say stop, and stop broadcast is the big red button. And who doesn't want to put the big red button? Z table. When your critical value, or when your test statistic is 2.42, you get a area of 0.4922. 0.4922. Area 0.4922. If we subtract that 0.5, 0.0088. I was joking. 78. Around to 3 places is 0.008. I'm going to verify this here. 0.5 minus 0.4922. Yeah, it's 0.0078 or 0.008. Anyway, that's the p-value, 0.008. And because p is less than 0.01, that implies we have very strong evidence to reject null. All the results from calculating the p-value, and I'll give you some bonus points here. Since it's 2 10 parts, it'll be worth 50% for each question. I may give you up to 5 points for giving me both the p-value of 0.008 and the amount of evidence which it provides. Maybe I'll give you 2 points if you get some part of it, 5 points if you get both. Anyway, now I'll go on to question 2, which is where I believe a lot of students started, because this was a hypothesis test for mu, otherwise known as, insert the symbol, mu. Mu. Anyway, does wearing a tie change attendance? Now, the other one said increase attendance. This one says change. There's nothing that says bigger, better, faster, stronger, bigger, better, faster, more, fewer, less. It just says change. It just means different. Anyway, for a long time, I didn't wear a tie and had expected an average of 21 students per day, normally distributed. It's good to know that that's a normal distribution because my sample size, 13 days, is less than 30. My sample size is less than 30, and that's where I'm getting my standard deviation. It's important to know that the population is normally distributed, or else I can't operate under the appropriate t distribution. Anyway, that just goes back to the check of how big is your sample size. Is it bigger than 30? Nope. Better hope the population is normal, and it is. Lucky for us. The expected value is that I get 21 students per day, but when I was wearing a tie, I got 22 per day. The research hypothesis, HR, is going to be that mu does not equal, which is sometimes written like that, sometimes written as that, sometimes insert symbol that. I'm going to do that. I could do here. Insert symbol mu. And mu does not equal what I expect. And let's subscript that. This is Jeff being pretty bad at his keyboard shortcuts. I need to know those things, but actually I think that's Control minus. It's different shortcut for different interfaces. Boom. That's my research hypothesis, that that the true number of days, the true average number of students per day when I wear a tie is different from what I expect. This is a two-tailed test, so I'm going to have plus or minus some t-value. And it's a t-value because I have sample standard deviation. I know that for 13 days, which is my sample size, in fact, all that information is sample information, 13 days, I observed an average of 22 students, a standard deviation 1.2. That means S is 1.2. That's not little sigma, that's S of 1.2. Plus or minus. Now it's time to go back to that T table. Right button. Ah, didn't disconnect. One of these is the right one. That one's the right one. I didn't just stop this, did I? Good. Yeah, they... Cool. Back to the t-table. This is a two-tailed test. The 0.01 significance level, which means this is the column that we need. And we come down here to the bottom where it says Z, and we ignore that value because our standard deviation is S. We don't use Z. Our standard deviation S means that we have a sample size of 13 minus 1 means 12 degrees of freedom. This is the degrees of freedom row for 12 degrees of freedom. We had a sample size of 13, 12 degrees of freedom gives us a critical T of 3.055 plus or minus 3.055. It's that row from this column two-tail 0.01. 3.055. Stop. I realize now I keep hitting the wrong stop button. It's because when I go to screen share application window, I hit that to flip back here, and then the share button is right where the stop broadcast button is. So when I default to the position on the screen, you don't care. T equals plus or minus 3.055. That's my critical values. Sampling error is what I observe minus what I expect, otherwise known as 1 day. I got a 1 day increase. The standard error is going to be S divided by the square root of N. Let me find some Excel real quick. Standard error is S, which is 1.2 divided by the square root of 13. Rounded to 3 places. 0.333, because 1.2, which is my square root, divided by the square root of 13, gives me a 3-digit standard error of 0.03328, which rounds to 0.333, or 0 point. The test statistic is just the sampling error divided by the sampling error. Sorry, standard error. Sampling error over standard error. I'm so nasal I can't even say those things. This should give me a value about 3. Maybe even something around 3.01 if you used the floating version. Nope. Even then, we still get 3. So our test statistic is 3. Our critical value is 3.06 or 3.055. It looks like we are going to fail to reject the null. We accept the null, meaning we reject the research hypothesis. We say that, nope, wearing a tie has not caused a change in attendance. This was observed over the course of 13 days. 13 days is a pretty small sample size. And if we're going to talk about types of error, when you reject the research, it's possible that you've committed a type 2 error, which I think is what we did in this case. When you have only 13 days of observation, that's not very much observation. And in fact, that standard deviation of 1.2, which we observed, is pretty small. If we think about that as compared to the population, and because the population we know is normally distributed, if that standard deviation for the sample is the same as it is for the population, we're really expecting about 95% of days to have somewhere between 23.5 to as few as 19.5. It's pretty narrow distribution, pretty consistent attendance. But if we're able to shift that up by an entire student over the course of 13 days, that's a pretty big lift. A t-value of around 3 is a pretty large t-value. When we start getting into test statistics that are greater than 2, it's certainly going to provide some evidence. But with a two-tailed hypothesis here, 1, which is a pretty conservative value, if this had been a directional hypothesis, we may have come up with a different conclusion. Because if we had chosen a one-tail hypothesis, the way we did in the first example, a one-tail hypothesis would mean our critical value is not 3.055, but rather that it's 2.681. And that's with the same alpha. You get the same alpha, but a different number of tails. That moves your critical value closer to the middle because it puts the entire alpha into one tail as opposed to splitting it to 0.005 on one side and 0.005 on the other. Regardless, if this had been a directional hypothesis, you have a different critical value, which means you actually have a different decision regarding accepting or rejecting the null. It just goes to show that if you can propose a directional hypothesis, you should, because you're more likely to reject the null if your goal is to reject the null. Now, being good ethical researchers, our goal is not necessarily to reject the null or to support our research hypothesis or anything like that. But in actuality, people are looking for things that are real, whether it's a real effect or real difference. So be mindful of that. But also be mindful that for the most part, statistical software is going to default to two-tailed tests. So if you see that you have marginally significant results, that's important to say, oh, well, if I change my critical value a little bit, then it might change the way I observe these results. Anyway, there's your answer key for these two things. Now I'm going to go grade, because it's gorgeous outside, and what better things to do than to sit inside and grade your papers. See most of you tomorrow, if not Wednesday, and then I'll try not to